Hello, welcome to this lecture video. I am teacher Melai, and today we will be discussing normal curve and normal distribution. So for the outline of this topic, so we are going to talk about characteristics of the normal curve, the area under the normal curve, and standard scores in the normal curve, and of course, finding probability under the normal curve. So we have here figures A, B, C, D, E, and F. So in relation to the past lessons on statistics, particularly descriptive statistics, so you were taught that you can actually present your data either graphical or tabular form. And if your data is at least interval, then it is possible for you to determine there is a need for you to determine whether the shape of the distribution is normally distributed or not, especially when you are identifying what appropriate measures of central tendency can you use to describe your data. So in this video, we will discuss, of course, we will focus on the normal, or rather we are going to talk about more about normal curve. So for letter A, so just to review, we will just give a brief description of our charts or histogram. For letter A, this is a unimodal. It is also called uniform histogram. It looks like a rectangular shape. And then for letter B, it is actually a U shape. So it is bimodal because it contains two highest frequency. And with respect to the mean, or rather with the respect at the center, so it is symmetrical. For letter C, so we have a bimodal curve. Letter D, it is a J shape because of it, the figure that it forms. It forms J shape. It is also unimodal because it contains the highest frequency. Letter E is also unimodal and it is inverse J shape. While for letter F, this is also unimodal and it is also symmetrical with respect at the center, just like with letter B. Now, using histogram, you can determine the shape of the distribution. So by, of course, drawing curve to your histogram. So just like with letter D, for instance, so this is the shape that you formed, and letter E, and then letter F. So for letter D, so this is the negatively skewed. Letter E is the positively skewed. And letter F is our normal curve. So we also have the values of rather an indication for the mean, the median, and the mode, that if the mean is equal to the median and is equal also to the mode, so we use the symbol M sub D and M sub O for mode and M sub D for a median. We say that the shape is normally distributed. While for letter E, so the highest value is the mean, the lowest value is the mode, and of course the median is located at the center or at the middle. It is positively skewed. While for letter D, so the highest is the mode and the lowest is the mean. The median retains at the center. It is negatively skewed. Okay, so as mentioned, we will focus on normal curve. Now, let's talk more about the normal curve. So the person behind it is Carl Gauss. That's why it is also called Gaussian distribution. And this is the formula of our normal distribution in mathematical function. So it is f of x is equal to 1 over sigma multiplied by the square root of 2 pi times e raised to negative 1/2 multiplied by the square of x minus mu all over sigma. So this sigma symbol is the sigma and the symbol is the mu. The mu represents the population mean, while sigma represents the standard deviation. So sigma is the standard deviation. So looking at this formula, we can see here that almost all of the values here are constant. Of course, the value of 1 cannot be changed. The value of 2 pi, because pi is 3.1459, and then the value of our E is 2.71828, which means the shape of our normal curve, or rather the how it looks like, depends on the value of our sigma and mu, or the standard deviation and the mean. Okay, so let us look at that. Let us explore. Okay, so let us move this to the So let's move it at the center so that it will represent the value of our mean. Okay, so this is the mean. So as you can see here, rather, this is the mean, it is 0, and the standard deviation is 1. So as you can see here, the normal curve, so it has a mean of 0 and has a standard deviation of 1. Now, if we are going to move the value of the mean, so let us move the value of mean to the right. So it moves to our right, the value of mean increases. While if we move it to the left, the value also moves to the left and it decreases. It means that the mean, so as the value of mean decreases, so as we move it to the left. But the shape of our curve remains. However, if the value of our standard deviation will be increased, so it moves down because of the spreadness of our curve increases. While if of course we decrease this, so it will look like this also. So it will move at the center. So that is how it how it affects our normal curve. So let's go back to our PowerPoint presentation. So for the normal probability distribution as mentioned, so now how does the standard deviation value affects the shape of the f of x? So we were able to see if it is 2, 3, or 4. So we have this the figure. So the green one is the higher value, while sigma for 2 is the less spread, and more spread for sigma is equal to 4. While for the value of the mean, so if we also change the value of the mean to 10, 11, 12, so it will look like this. So it moves to our left, or rather to our right as we increase, and it moves to the left as we decrease the value of the mean. Okay, so what are the characteristics of the normal distribution? So as shown in our review, so mean, median, and mode are equal. We were also able to see that it is symmetric at the center, so that is a check. And then this is additional. If we will consider now, or we are going to consider the area under the normal curve, the total area under the normal curve is 1. The normal distribution is also a continuous distribution, so which means that we can increase the value of x positively and negatively, and of course we cannot expect that there will be some holes or discontinuity because, as mentioned, it is a continuous distribution. So this is already mentioned. It is a unimodal. The normal curve is also called a bell-shaped curve simply because it forms a bell-shaped curve. Okay, so let us move to the area under the normal curve. So as we mentioned, that the area under the normal curve is 1, and we can represent this as 100%. So we made mention in our target objectives or topics that we will also consider probability, because this one, the total area, which is 1, can also be represented into 100%, representing also a probability. So since the mean is located at the peak of the curve, then half of the area under the curve is above the mean and half of it is below the mean. So the area, half of the area is of course 0.5 and another half is 0.5. So take note, we of course always have a positive area. We do not have a negative area. So whether it is located at the left or it is located at the right, so it is a positive area. So we know that half of it is equal to 0.5 because the total area is equal to 1.